So the next topic is going to be insertion. So in the last class, we have seen about an arrays, and in the arrays, at first we have seen about an what is meant by data structures, and then linear and non-linear, and then we have seen the purpose of linear and non-linear, and then the linear type is there are many types are there. The first type we are seeing is arrays. We have seen arrays mean nothing but storing multiple data under a single variable. A of 0, A of 1, A of 2, A of 3, and then it will store in continuous memory locations. And then here we have an index, where index is nothing but an address, where each address can store a maximum of 4 bytes. And then we have seen different types of operations. So the first operation we have seen is traversal, visiting all the data in an array. So the next operation which we are going to see today is about an insertion. So here insertion means I can store a data at three places at different locations. Either I can insert a data at the initial beginning stage, or I can insert a data at end of an array. Otherwise, I can insert at any point of my array or any position in my array. The three possible situations are there. As a user, if I give an insertion at specific position, then that covers all the scenarios, specifically, if I want to insert a data at the beginning, then for that you can specifically write a code. The other way is insert at the end. So we will do the programming for three scenarios. The first scenario is going to be insertion at specific position. Insertion at specific position. So as usual, what we have done over here, we have declared an array size and then size variable and I. So we have got the we have got the size of the array from the user, and then we have entered data in an array. So now we have got this. Now we have got this. After this running this program, we will get this output. Okay, so now we are going to insert a data at specific position. So now, before going to the program, then at first we will see how do we do it in by means of in the table way. We will go to the coding. So for example, the number which I want to, the data which I want to store in the array is something called 9. And then the position which I want to do it on uh, third position. Third position. So at first, what do I do? So at first, I will check for whether the size is more than the array size or not. Whether the size is more, if size is, suppose for example size which I have given is 36, but the arrays can store maximum 35 only. So then I can't store any data. So array is full. But where in our scenario, the size is not full. We have given size as a 4 only. So array is 35. So in our case, it's not full. So we'll go for a second scenario. So now what I'll do, I will get the corresponding data and position from the user. I'll get the data and position from the user. So now once I get the data and position from the user, then what do we check? Whether the position is valid or not. Whether the position is valid or not. So how do we check the position? So the position should be it should be within the range of less than or equal to 0. The position should be within the range. Okay, the position should be within the range of 0 to 3. 0 to 3. Okay, so that means that 1, so 0, 1, 2, 3. Okay, so I can give it as an and one more option as an uh, the position should be more than invalid position. Understood? Okay, if I want to insert a data, the position I will ask the user the position. Where do you want to insert? So I should check that whether it is within the array size or not. Within the array size or not. So if the position is more than size plus 1, it is invalid position. If position is less than 0, it is invalid position. So whatever in between from 0 to size plus 1, we can insert a data over there. So if this condition satisfies, if the position is valid, then we'll go for a next stage. So now what do we do over here? I will check the position. Okay, where do I want to insert? So now at first I will consider n I is equal to minus 1. Why minus 1? I will tell at last. Okay. So for time being, just you know it as a position minus. And then after every switching, I will decrement I. So now for in this case, I is 3 now. So now I is 3, right? So I will switch this data of 2 to the fourth position. Okay. So that time 3 is greater than the position minus 1. Position is 3 and then 3 minus 1 is 2. Condition satisfies. Okay, so then I will decrement psi. I becomes an 2. I becomes 2 now. So now once again for loop. Okay, so then what happens over here? So now I will check for I is 2 now. So now 2 greater than 2. It's not. It is not. Okay, so because I want to insert it at the position 3. So this is the position. This is the position. So then this loop gets failed. This loop gets failed. Okay, once this loop gets failed, then what I can do, I can store the new data over in the position. Okay, so a of is equal to and data, and then at last I'll increase the array is full. Okay, else I will ask the user to I'll ask the user to enter the data. Scan the data. And then ask the user the position where they want to insert. And then scan the position. So once you got the data and position, then I will check for the position is valid or not. So for to check the position is valid or not, here we have a case. It should satisfy this condition. Okay, if it's not, that means that it's invalid position. So if the position is less than equal to 0 or position is more than size plus 1, then I will print it as a invalid position. Invalid position. Okay, else I will use an for loop over here. For here I will check for an I is equal to size minus 1, I more than position minus 1, and I once. So now what do I do over here? So once A of this data will be gets switched over here, right? A of third data has been moved to the A of fourth position. So here I is size minus 1. So A of I plus 1. A of I plus 1 equal to A of I. How it happens over here? So here we are given as I is equal to 3. I is equal to 3. But I want to switch this data to the fourth position. Okay, so A of I is equal to A of I plus 1. This data will be moved to the A of fourth position. So that's why I have given A of I plus 1 is equal to A of I. So and then, for example, by case, if I given the position as here 2 over here, then here the position minus 1. 2 minus 1 is 1. So then 2 less than 1. Then what happens over here? If this condition not satisfied. This condition satisfied. 2 less than 2 more than 1. So then what do we do over here? I will switch this data of 3, copy it up, and then put it over in the A of third. A of third. Okay, so then I will decrement the I. I is equal to 1. Then I is equal to 1. And then here 1 more than 1. This condition does not satisfy. Then what happens over here? I should correspondingly I'll store the data value over in the second position. Second position. So at last, where do we store the data over here? Now in the A of position, I will store an data, and then I will. So that means that directly to store at the last position, the A of fourth position. If I give size as a 4, then to store until the data from size minus 1. So until A of 3 to store the data. So since I found insert the data at the end, so A of 4, directly I can store the A of size is equal to data and then increment the size by 1. Increment